Hello, once again, wonderful people. Let us try to complete this question 1. In 1.2, we have a simultaneous equation x plus 2 equals 2y and 1 divided by x plus 1 divided by y equals 1. We know that this is a simultaneous because we are working with two different alphabets, having the first equation and the second equation simultaneously. We can work this. We can use the Kramer's rule in order to solve the problems here, but we will stick to the grade 12 standard way of doing things. So we will solve this simultaneously. So how do we go about this? So let us try to find the solution to this. This x plus 2, that is equals to 2y, and 1 over x, 1 over y equals 1. So I'm going to name these equations as equation 1 and equation 2. Simply equation 1 being an equation where I can simply make x or y the subject of the formula, and then equation 2 being the one that I will need to substitute equation 2 in equation 3 in equation 2. Let me just show you how this is done. So the first one, I'm going to say, okay, from equation 1, and I write equation y, which is x plus 2 equals to y, and from this I'm making x the subject of the formula, yx, because it has a coefficient of 1. I cannot make y because it has a coefficient of 2. That is why I'm doing this. So I'm going to say that x equals 2y minus 2. Now the equation where I was able to make x the subject of the formula, I will name that as equation 3. Now I'm going to take equation 3 and substitute into equation 2 because I haven't done anything in equation 2. So the first step is to write equation 2. So I'm going to say I will substitute 3 in 2. Write down equation 2, 1 over x, 1 over y being equals to 1. This is the standard procedural way of looking at things. So in this equation, 1 over x plus 1 over y equals 1. I'm going to substitute 2y minus 2 where I see x. Now, here I am, 1 over, I see x, I'm writing 2y minus 2 plus 1 over y, that is equals to 1. Remember, I'm substituting in this equation. Where I see x, I'm writing this. Right. From here, whenever I have a fraction and a fraction separated with addition, I need to take out an LCD, the lowest common denominator. So that would be y into 2y minus 2, because on my denominator from this and this, I have x, there it is, I have this, there it is, to show that they need to multiply one another, because that's exactly what we do when we have a fraction. So what am I going to do from here? This into this goes once, this times that is y, addition sign. This into this goes once, this times this, it's 2y minus 2, and this is equals to 1. Very important that we see that. Now there are some like terms that can be collected from this. Y plus 2y, 3y minus 2 divided by y into 2y minus 2 equals to 1. Very important. Now from here, what is it that I can do? I can take out an LCD, I can do anything. I just have to multiply both left and right by the denominator that I have. So how do I do this? I have my 3y minus 2 divided by y into 2y minus 2. I'm multiplying by y, 2y minus 2. 1 multiplied by y into 2y minus 2. What have I done here? I have multiplied both left and right by the denominator, which is y into 2y minus 2. What I do on the left, I was also employing to do on the right. From here, I know you are numerator, you are the denominator, separated by multiplication. Therefore, I have the privileges of saying that into that goes once, and I'm left with 3y minus 2. Multiply here. 1 multiplied by the whole of this becomes exactly that. But I can say y times 2y, it's 2y squared. Y times minus 2 is minus 2y. Now things seems a little bit simpler for me to work with. Remember, always the coefficient of y squared has to always be positive. Therefore, I need to take these ones to the right side. Right, so this side I will have 0. I have my 2y squared minus 2y. Take this to the other side. Negative, take this to the other side. Positive. Right, from here we can try and simplify things. I have my 2y squared minus 2 minus 3 is minus 5. So I have 2y squared minus 5y plus 2. Now I have a quadratic, and the coefficient of y squared is 2. Becomes a little bit tricky for many of the students, but worry not, Mageba is here. Now what we are going to do here, please, you need to listen attentively here. So I'm going to say, okay, in fact, let me do this. You're going to take this 2 and multiply it with this constant, and you will get 4. So you will have y squared minus 5y plus, you said 2 times 2 is 4. Very, very important that you understand this. And then now try to factorize this. So 0 equals the factors of 4 that can give us 5. We know that's 4 and 1. Y, 4 and 1. The bigger number takes the sign of the middle term. Remember, when you multiply these two, you must get positive 4. So if this is negative, this also has to be negative. Negative 1 times negative 4 is positive 4. Minus 1 minus 4 is minus 5. So we are correct in this. And now what you need to do here, since you took that 2 and you multiply that 2 with this 2, you got 4. You take that 2 and you divide both these numbers by that very same number. You will divide here by 2, you will divide here by 2. 0 equals, and then now when you are here, you will say, can 2 go into 1? No. Therefore, you take this 2 and you multiply it with this 1. You get 2y minus 1. You have your minus 1 there. And then you come here. You have your y minus, you say, can 2 go into 4? Yes, 2 times. And you are done. Here you are. And now you say 2y minus 1 equals 0, or y minus 2 equals to 0. Y equals 1/2, or y equals 2. Now you are done with this. You have the values of y, you just have to go and find the values of x. Okay, wonderful people, those are the values of y. Now let's just quickly try and find the values of x. So I can name this as my equation 4. So I'm going to substitute 4 in 3. So where is the 3? There it is. X equals 2y minus 2. And then I can take the value, the first one of 1/2. I can substitute here. I can say 2 into 1/2 minus 2. This into this goes once. You have 1 minus 2, which is minus 1 for the first one. And for the second one, you can say 2y minus 2. You can say 2 into 2 minus 2 and find a value of 2. And simultaneous equation is complete and dusted. Right, and from here, let's go and solve the very last one. As you can see that the board is full, I'm just going to erase the whole of this. So this is fine. It doesn't mean when you get these things correct, you are a genius. No, everybody can get this right. So let's go to 1.3, and we want to find the value of m plus n. We are given that 2 to the exponent m plus 1 plus 2 exponent m equals 3. Wonderful people, let's continue in 1.3. We need to find m plus n. I will assume that m plus n are the integers. I don't remember exactly the instructions that were provided for this. But this is what we have on the board: 2 exponent m plus 1 plus 2m equals 3n plus 2 minus 3 exponent of n. Right. So let me start first by copying down the problem that we have. I think this is going to help us a lot. So I'm going to write 2m plus 1 plus 2m 3n plus 2 minus 3 exponent n. So this is exactly what we have. And the second step that I think I need to employ in this is to break down m plus 1 into individual components. That is to say 2m 2 1 2m 3n 3 squared minus 3n. Why am I doing this? Remember, when you multiply, you add the exponents. So I'm trying to work out a common factor. There's a common factor in here. So I can say 2m 2 1 plus 1 3n 3 squared minus 1. I will assume that you understand the grade 9, grade 8 laws of the exponents. And then from here we will have 2 3 into 8. And from here I can try to group the like terms. So can you see what I can do from here? I can do the following. Let me just try to simplify this for you. And what I can do from here, taking this to that side, I'll get 2m minus 3, because, okay, let me just show you what I'm doing here. Let me divide by this. When I divide numbers of the same basis, I subtract the exponent. This into this goes once, and this is what I have. And then I can divide both sides by 3. Because there's a 1 there. If you take that to the top, it becomes a minus. Now I have this. The mighty Ndabezit. What do you do from here? Let me just write this here. I don't even know how I will ever get to m plus n, but I'm going to try my best. Now that I have this, I have no any other choice here. But what I think I can do, I think I can take this to the side. And equate this to 0. Of course, I cannot factorize this. But what I think I can do, I don't know whether there's a possibility of factorizing this. Let's try and see if this will work. Let's say 3 2m 2 minus 3 equals to 0, and when we are here, if I let this, for example, to be k, maybe this one to be p, let's see what we will have. I have k over 8 minus p over 3, that is equals to 0. I'm trying to do something here. I can multiply throughout by 8 times 3. So I can say k over 8 times 3, 8 times 3, 0. This into this goes once, 3k minus 8p equals to 0. And can I take out even a common factor here or something? There's none. There's none. So how do I work around this? How do I work around this? Am I allowed to say that 3k equals 0 or minus 8p equals to 0? But there seems to be a problem with this. So let me not do this. When I am here, will I be correct to say m minus 3 equals to 0 or n minus 1 equals to 0? Why am I equating the exponents? It's because I have a base with an exponent and 3 with an exponent. So what I'm saying is this m plus n, since I have this with an m, since I have this with an n, therefore I can conclude, find the values of m plus n. I can say m minus 3 equals to 0 or n minus 1 equals to 0, since this is an equation. And I can say that m equals 3 or n equals 1. So m plus n will be 3 plus 1, which is equals to 4. So this is one possibility of looking at this if I equate the exponents, because the bases, this base carries an m, this base carries an n, and there's nothing I can further do. You have saw as we have tried, there's no way out. So all we need to do, since we are working with an equation, is to say m minus 3 equals to 0 or n minus 1 equals to 0. But there might be other ways. There can be, in fact, other ways of looking into this, and you are more than welcome to argue in this and find different answers. Unfortunately, I don't have a memorandum for this, but I think this is all what we can do. Honestly, I think so. I think this is all what we can do.